Stem cells are the only reagent, the only thing known to medical science, the only technology in the world that has the capacity to treat every single human disease.
I think we're entering a revolution with stem cells that can fundamentally not just affect medicine, but society as a whole, possibly even change life expectancy, the duration of life.
We've never, in the modern era, endorsed the instrumental use of human beings in any of their stages of development for medical research. That means that from here on out, we're going to have many arguments about what uses can be made of living human organisms, and embryonic stem cell research is the first symbolic battle on this much larger discussion.
Heart disease, Parkinson's, diabetes, cancer, strokes. These are among the leading causes of death in the United States, with millions more still alive and suffering. But what if science discovered a cure for these maladies? What if medicine could reverse degenerative diseases, regenerate healthy tissue and damaged organs, repair spinal cord injuries, and eliminate paralysis? Would it be worth the price to pay? Would it be worth any price? In 1963, researchers defined special cells in the body that have the ability to regenerate and reproduce other kinds of cells. They called them stem cells. In 1981, scientists derived the first embryonic stem cells from mouse embryos, which ultimately led to the pursuit of human embryonic stem cells.
1998 was really the beginning of human embryonic stem cell research. That was the year that it was determined that you could actually create them in humans. So it did change everything, and it created an entire new field.
Some claimed it was only a matter of time before these cultured stem cells could be used in medical therapy for a number of significant degenerative conditions. But there were problems.
There were those that looked at the promise of it, and there were those that had great fear about it, that this would cause embryos to be created simply for the purpose of later destroying them and creating embryonic stem cell lines. So there was a huge polarization about it.
In 2001, in response to these ethical concerns, the Bush administration became the first to allow federal funds to be used for embryonic stem cell research, and only on specific stem cell lines already created.
This allows us to explore the promise and potential of stem cell research without crossing a fundamental moral line that would sanction or encourage further destruction of human embryos.
Researchers could continue to engage in privately funded and state-funded embryonic stem cell research, but the federal government was divided and political war erupted.
Do not destroy innocent human life for any reason.
Stem cell research is an integral part of finding a cure for this disease.
The disposable human life mentality.
Why isn't it getting done? And my answer is, I don't know.
I can't see where I'm going.
You can't see where you're going. Okay, this goes.
I thought it was a very well thought out and indeed brave decision, because if you look at any decision where there are competing sides, if you have upset all sides, you've probably made the right decision. And that's indeed what he did.
Celebrities joined the debate, providing a strong emotional appeal, some of them personally affected by the issue.
I have a keen interest in research, and I'm deeply disturbed by unreasonable attempts to block scientific progress. Our government's supposed to do the greatest good for the greatest number of people. Beyond that, we have a moral responsibility to help others. Time is absolutely critical.
I have found comfort in my heartfelt view that embryonic stem cell research is truly life-affirming.
We have an extraordinary opportunity to eradicate these diseases that are haunting our friends and families.
At this point, only embryonic stem cells can produce enough of the neurons needed for cell replacement by a factor of millions.
You know, I'm concerned that celebrities are being used to advance a cause here. I'm concerned that they're being used, that they're not given perhaps all of the facts, that perhaps they've been sold a bill of goods, which a lot of this research is advancing this kind of hyped up, we need to do it now.
And you find a public policy advocacy campaign That is pretty awesome, but is also profoundly deceptive and disingenuous.
So why the controversy? Why the polarization? Should there be ethical restrictions involved in stem cell research? Or should science be unhindered by moral restraint? The human body is composed of hundreds of types of cells. Stem cells are unique in that they can repair damaged organs and rebuild vital tissues in the body. They accomplish this by multiplying and transforming into cells that are needed for repair.
Well, there are many different types of stem cells, but there are two main categories, adult or embryonic stem cells. An embryonic stem cell line begins with an embryo, and those embryos are usually donated by a couple who's gone through fertility treatment and has completed their family.
This fertility treatment is called in vitro fertilization, or IVF, which refers to the creation of fertilized embryos outside of a woman's womb.
We then grow those embryos out to what's called the blastocyst stage. The inner cells inside this embryo can be removed and can be plated out, cultured, and turned into a stem cell line.
The embryonic blastocyst can also be implanted into a woman's uterus to grow into a full-term child.
So in order to form embryonic stem cells, you must destroy the embryo. That's the only way that it can be done using those IVF embryos.
The other type of stem cells that researchers are working with are called adult stem cells.
By adult, we mean that they already exist in our body in different organ systems, and they're there to repair damage and aging to that body throughout our lifetime. And virtually every organ appears to have a stem cell compartment.
The main difference between the two types of stem cells is that the embryonic stem cells have the property that they can divide indefinitely. Adult stem cells can't do that. You grow them in the laboratory for a while and then they stop growing. The other property that the embryonic stem cells have that the adult stem cells don't is that they can turn into any tissue of the body, whereas adult stem cells turn into the tissue that they were derived from.
The ability to turn into any tissue of the body is called pluripotency, which makes the embryonic stem cell highly adaptable in fighting degenerative diseases. Despite its scientific progress, ethical concerns about embryonic stem cell research have been voiced by doctors, scientists, women's groups, and ethicists.
In embryonic stem cell research, what makes the controversy so intense is that a nascent human being, that is an embryo at the 1-week stage, is being destroyed for its body parts, if you will, its stem cells. It is to use nascent human life as a corn crop ripe for the harvest.
Well, there are probably as many definitions of human life as there are scientists. But one thing I'm absolutely convinced of is that an embryo in a dish is not a human life, and it's certainly not a person.
Well, I don't think that's a scientific statement. I think it is a human organismal life in the dish. And it's a common tool of rhetoric in political arguments to win by redefining the terms. I don't think either side should do that.
Well, the scientific definition of human life, I think within the context of what we're talking about is that human life begins at conception.
It's admittedly very tiny. It's admittedly in its earliest stages of development. And so the question is, does it have the moral worth that we assign to later stages of human development?
Fertility treatments are now so effective that the vast majority of time we have excess embryos. And the question is, what do we do with those embryos? Do we pick them up? Do we just throw them in the trash? Do we discard them? Or do we find something useful to do with them?
The issue isn't about leftover embryos. The issue is whether or not we can use human life instrumentally.
To those individuals who may have moral issues with human embryonic stem cell research, I would say, I would advise, I would plead education.
Although the value of human life and the issue of personhood are an ongoing concern in the debate over stem cell research, it would be limiting to reduce that debate to a pro-life versus pro-choice battle. The reality is that some doctors, scientists, and ethicists of both pro-life and pro-choice persuasions continue to be concerned about the consequences of stem cell research. One of those consequences is women's health. Normally, a woman's ovaries release 1 or 2 eggs a month. In order to extract many eggs for in vitro fertilization, or IVF, doctors use what is known as ovarian hyperstimulation, injecting powerful fertility drugs into a woman's body to force it to produce a dozen or more eggs at a time. The eggs are then extracted from the uterus using a needle.
Nowhere in the world has anybody done any research on the aftermath of the drugs on women who've been donating, or often it's not donating, selling eggs across any of the countries that are involved in this kind of trade. They become forgotten.
I'm actually just back from London, where I attended an international conference on natural cycle minimal stimulation IVF. And for 2 days I listened to world-class fertility specialists, embryologists from all over the world talking about how dangerous the drugs are that they use on women for fertility treatments.
We don't know the long-term effects of taking these medications yet.
So in terms of, are there long-term studies on these drugs? No.
One of the dangerous conditions that doctors are becoming increasingly aware of is ovarian hyperstimulation syndrome, or OHSS.
So it's a syndrome, OHSS, that's the result of the ovary being kind of put into hyperdrive. It's producing a lot of eggs. And when you do that to a person's body, it also produces other changes in the body, which can actually, in some people, can have the risk of death.
Ovarian hyperstimulation syndrome is a reality. I was the person who contacted the mother of a girl who died from it. It's a serious consideration, and if you go on to the websites of IVF clinics around the world, you find that it's acknowledged as a risk.
Well, the list of dangers for egg retrieval in women would include the OHSS, which would, in itself, put a woman at risk for pulmonary complications, fluid imbalances, stroke, death. Besides OHSS, there's also the risk of clotting issues that can occur from the drugs alone. You can also have, in the future, you can have adhesion, so you can have problems getting pregnant or difficulties in the future. And I think that in terms of the women who are considering voluntarily or even for money donating their eggs, they need to be aware that this is not a procedure that is not without risk. And one of those risks, unfortunately, is death.
One woman who was permanently damaged by using the IVF drug Lupron and barely escaped with her life is Calla Papadimas.
At the end of my college career, I actually responded to an ad in the Stanford newspaper advertising $50,000 for an egg donor with certain criteria. The first drug they sent me is called Lupron, and its job basically is just to stop the donor's menstrual cycle to be able to be synced with a surrogate so that that person can carry the child. What was not known was that I had a small benign tumor on the pituitary gland. So when I started taking that drug, I became very ill because basically that tumor had a catalyst and caused a major stroke. So I was paralyzed on my left side and legally dead, I think, twice or 3 times. And I found out the only use the FDA ever approved that drug for is men in end-stage prostate cancer who are dying, and it makes them feel a little bit better. And I'm not the first person who had this almost precise result after this medication, that there were 8 or 9 people before me. I was just the first woman. A general practitioner said at one point to my mother, the industry knew that this would happen sooner or later. They've just been rolling the dice and it fell on your daughter. It was worth the money to them. I mean, I can't have my own children now.
When a woman is infertile, she inherently has a higher risk of breast cancer and she has a higher risk of ovarian cancer. And so when you look at studies of women who have taken these drugs and it shows an increased risk of cancer, let's say, in some studies, you have to ask yourself, is that because she was infertile or is that because she was taking the medications?
My daughter, Jessica Grace Wing, saw an ad offering quite a bit of money, and she did donate her eggs, in fact, 3 times altogether. And then she went on with her life, And 5 years later, she was diagnosed with advanced colon cancer, and within 2 years, she was dead. She already accomplished so much in her 29 years, and she could have, if she had had 3 times as long, I can only imagine what she would have done. We have her opera, we have classical music she's composed, and she's gone.
I think there is not an adequate informed consent. I've seen some informed consents when they will say, well, there may be a risk of cancer. Well, you need to say the studies have never been done to see whether there is a risk of cancer.
Informed consent means that you know the risks as well as the benefits, and we don't know the risks. The young women don't know the risks. I want an egg donor registry. I want follow-up of these egg donors so we know what the risks are, so that young egg donors can actually give informed consent and know what they're getting into.
The vast majority of biomedical researchers in this country identify embryonic stem cell research as the most promising source of treatments.
We saw the potential to cure the diseases that affect 100 million Americans.
Embryonic stem cell research could unlock the doors to treatments and cures to cancer, diabetes,
Alzheimer's, Parkinson's, multiple sclerosis,
and cancer, and I could go on and on and on.
If we have a scientific opportunity to treat and cure disease, we have a moral responsibility to support it.
In spite of its promised miracles, embryonic stem cell research has had very limited success in animal tests and has been plagued by several problems that have prevented it from clinical application to human beings.
The value of the embryonic stem cells is that they can form every cell in the body. They're called pluripotent. Of course, the disadvantage with them is that because they can do that, they can do it in a disorganized way and form teratomas, or cancer of all types of tissue that's completely disorganized.
One of the controversies about embryonic stem cell transplantations is immune rejection. And because the embryonic stem cells are not related to the person who's going to be receiving a transplant, undoubtedly there will be some immune rejection. And so it's possible that they will need to take immunosuppressive drugs in order to not reject that transplantation.
In spite of the ethical issues of destroying human life and the danger to women's health, as well as the scientific medical issues of cancer and tissue rejection, scientists remain intent on pursuing embryonic stem cell research. But there is a form of stem cell research that has avoided these ethical and scientific problems and provided help to suffering patients around the world. That research is adult stem cell research. Adult stem cells, also called somatic stem cells, were originally discovered in bone marrow as unique and somewhat rare cells that renew the blood and immune system and repair diseased and damaged tissue, like tiny cellular ambulances for the body. Since that time, scientists have discovered adult stem cells in many organs and tissue, including blood, muscles, skin, liver, brain, and even fat tissue.
These adult stem cells, the advantage is that they don't form teratomas. And they are very faithful to the compartment they come from. So a liver stem cell forms liver, a muscle stem cell muscle.
Well, there have been reports that some adult stem cells do have what's known as plasticity. That is, instead of dividing and becoming a liver, they might divide and become a muscle cell.
Adult stem cells are wonderful cell types. You can procure them from an adult. You don't have to use embryonic stem cells. There are advantages, but there are also disadvantages. These cells don't make every single cell in the body. Embryonic stem cells do. Adult stem cells usually can divide a handful of times, 1 becoming 2, 4, 8, 16, whereas embryonic stem cells can divide ad infinitum. They can make more tissue.
Adult stem cell research is having much greater success. They don't cause tumors, for example, as embryonic stem cells do. So they're now in early human trials for things like spinal cord injury. We have had paraplegics and quadriplegics have had feeling restored in early human trials using adult stem cells.
The fact of the matter is that adult stem cells have been used for decades to treat disease. Embryonic stem cells have not been used to treat disease at all, except in animal models. In that respect, adult stem cells win hands down.
With new discoveries, adult stem cell research continues to demonstrate promise for treating many diseases, including cancers, brain, ovarian, breast, and leukemia, autoimmune diseases like diabetes, other leading causes of death such as heart disease, Parkinson's disease, and strokes. Adult stem cells have helped some children avoid a life of pain from sickle cell anemia. Others, with severe spinal cord injury, are learning to walk again.
But what you get from this kind of approach is a patient-specific cure. There's no middleman involved, and there's certainly no drug company that's going to get rich as a result of it. And I think a lot of the El Dorado in the stem cell world is to find some kind of product that they can sell, as opposed to a treatment that I do for you to cure you.
And curing is exactly the kind of possibility that adult stem cell research seems to be approaching.
In 1995, I was diagnosed with multiple sclerosis. Periodically, my exacerbations would become worse and worse as it went on. The time in the hospital became longer. The treatments became larger. I said to my neurologist, what happens if my body don't respond to the treatment? What do we do next? And he really couldn't answer me.
In 1994, I was diagnosed with severe refractory Crohn's disease. I took all conventional medications, prednisone, steroids. At 29, I basically became bedridden. I was on chronic pain management all of the time. I had an ileostomy, and that is a bag on my side for waste removal, and ended up in and out of a hyperbaric oxygen chamber with an open wound where my intestine had perforated. I was told that there was really no help for me whatsoever, and that there was nothing I could do, and that basically I was going to die.
I have a disease called scleroderma, and it's an autoimmune disease. It's known as the disease that turns people into stone. My skin was getting very tight all over my body. Raising my hands over my head would feel like my stomach was ripping because the skin was so tight. But then it started to harden my lungs. That's when I was told by my doctor that I had a 50-50 chance of surviving 5 years.
I was 15 when I was first diagnosed with lupus. By the age of 18, right before graduation, I had lost my kidney function. I was 20, almost 21, when I was pretty close to the end of my life.
The lupus had also deteriorated her heart. She had severe cardiomyopathy to the point where your heart was operating at 10% capacity. She was already dying from the disease, but another complication that she had was something that was eating away at her flesh, which caused an immense amount of pain. It starts as a bruise, and then it starts to eat away at the flesh to where it opens up, and it eats all the way down nearly towards the bone.
It was excruciating.
They didn't know how much time you had left, but they knew it wasn't very long, and they just wanted us to do our best to make you comfortable.
Till I died. We had all my friends and family come in, say goodbye. It was...
I mean, Karina had already made her funeral arrangements.
Yeah.
You had asked to be cremated.
20. Yeah, at 20.
Then I found out about adult stem cell transplant at Northwestern Hospital in Chicago. I would not be able to stand here today had I not had a stem cell transplant. I probably would not be here at all.
Having this stem cell transplant saved my life, and it gave me hope that I will be here in 5 years. Before this transplant, I really didn't have any hope. So I find a lot of the frustration I have is just a lack of education. People just don't know about it. Regular people don't know about it. Doctors don't know about it. I don't understand why it's not being shouted from the rooftops. I mean, amazing things are being done with your own stem cells.
At this point, stem cells were a very ethical and moral dilemma, and there was a big debate surrounding it and some issues and concerns. But after reading it and sharing it with some of the doctors, the idea wasn't that the stem cells came from embryonic stem cells, but they in fact came from Karina's own stem cells. They were cleaned and purified to the point where the disease was stripped from the new stem cells and then reinfused back into her, just like a blood transfusion.
So it was pretty much like rebooting a computer.
They do the adult stem cell, they reboot your immune system, and I've been MS-free now for 5 years. This July is my 5th year. I live a normal life, I coach hockey, I play racquetball, I golf. Everything is good. I cannot complain about anything in my life at this point. With medicine, it's tremendous. If I didn't do the stem cell transplant for my MS, who knows, I would probably be in a wheelchair today.
Really, it was against all odds. She made medical history and medical news. Her doctors were so amazed. And from the point of reinfusion, I'd say within 2 weeks, things started dramatically changing.
Hi, Uncle. I didn't want to forget you, and I love you too, and Boo and Jay and Abu. But I love you too, Uncle. And I'm gonna get better for you guys too.
It saved my life. It gave me a second chance at life. And without this option, I would have never had that.
I think not only did it save her life, but she is completely normal today.
Yeah.
She's clinically normal. She's symptom-free. She's been able to resume a normal life and pick up right where she left off.
Adult stem cell research has provided benefits to human beings through clinical trials and treatments of over 70 diseases based on peer-reviewed, published results with patients.
I'm glad you're here.
Me too.
Embryonic stem cell research, still in its infancy, has not yet resulted in human treatments. Only recently have biotech companies approached the FDA to begin the first human tests of therapies created with embryonic stem cells.
So all the questions that are out there now about whether adult is better or whether embryonic is better, I think these questions are going to be answered soon. They're going to be answered in the next 5 to 6 years. It's just a little unfair to take research that's been around for 40 years and compare it to research that's been around for 10 years.
The controversy over these two kinds of stem cell research may not be so simple as a matter of years, because another issue is behind the stem cell debate, bringing with it another set of questions and controversy. That issue is cloning. In June 1996, Dolly the sheep was the first mammal cloned by scientists in Scotland using somatic cell nuclear transfer, or SCNT.
Somatic cell nuclear transfer refers to taking a body cell and placing it into an egg that's had its genetic material removed. That egg is then able to take that cell back in time. It's able to take it back to an immature cell. And from that immature cell, you can create an embryo.
If it was ever to go into a uterus, there would be a chance that you could then clone the human from which it came. That is called human cloning, or reproductive cloning. That's illegal.
Reproductive cloning of humans is not only illegal, it raises serious ethical questions of social justice and personal conscience, questions raised by some Hollywood movies as moral tales of warning. Would human clones be property? What rights would they have?
You're clones. You're copies of people out here in the world.
What?
Clones?
What?
Copies? What are you talking about? Some hag trophy wife needs new skin for a facelift, or one of them gets sick and they need a new part. They take it from you.
Frightening images of human beings stored for medical exploitation are often diverted by appeals to suffering and the promise of perfection of the human organism. But do the ends justify the means? And who defines perfection?
First, we may as well decide on gender. Have you given it any thought?
We would want Vincent to have a brother, you know, to play with.
Of course you would. Hello, Vincent. Well, you have specified hazel eyes, dark hair, and fair skin. I have taken the liberty of eradicating any potentially prejudicial conditions, premature baldness, myopia, alcoholism and addictive susceptibility, propensity for violence, obesity, etc.
We didn't want, diseases, yes, but...
Right. We were just wondering if it's good to just leave a few things to chance.
You want to give your child the best possible start. Believe me, we have enough imperfection built in already. Your child doesn't need any additional burdens.
Taking a page from another famous sci-fi scenario, some storytellers have even predicted the horror of cloning animal-human hybrids, splicing the genes of humans and animals together to create new species.
Well, I don't see how any of this specious nonsense justifies these monstrous disfigurements.
Well, very simply, they represent a stage in the process of the eradication of destructive elements found in the human psyche.
The animal-human hybrids of Dr. Moreau may seem like distant science fiction, but a form of hybridization using human DNA in rabbits' and cows' eggs has already been legalized in Britain.
The proponents of animal-human hybrids are giving us the same arguments that they offered for embryonic stem cell research. If we do this, we'll be able to do a lot of wonderful miracle cures as a result of it. When we expressed great horror about this, the answer to our great horror was, well, we won't allow them to develop past a certain stage. There's never a principle of you shouldn't do something in the first place.
These cinematic nightmares of a brave new world are not yet a reality. However, there is a growing debate over the moral equivalency of therapeutic cloning and reproductive cloning.
I think there's a dramatic ethical difference between doing reproductive cloning, which we know from animal studies frequently leads to abnormal animals, or if it were ever tried in humans, to abnormal humans, to a process that creates a stem cell line. In my mind, it's a much more ethical thing to do. It's certainly something that can be used for the greater good.
But what if the best good would be to carry this out to 6 weeks and take stem cells from a 6-week embryo, which would require implantation in a womb or a substitute therefore? Would the greater good justify that? Well, why not? Once you've accepted the premise, how about 6 months? And you see, that's the danger of going down that road of the greater human good, because if the general purpose is to find cures at whatever cost, or to use so-called non-persons or people who are weak and suffering or perhaps even dying, you can end up in a society that basically, not literally but figuratively speaking, cannibalizes its own.
In America, only 6 states have banned all forms of human cloning, even though a recent Gallup poll shows that 87% of Americans in general consider it morally wrong. Because of this opposition to cloning by the majority of citizens, the biotech industry has pursued a political campaign of education and legislation. Opponents have described it as a campaign of deception. And the first deception they claim is the attempt by advocates to confuse the public by defining SCNT as something other than cloning.
Many people use therapeutic cloning and somatic cell nuclear transfer as synonymous terms, but they're actually not.
Cloning and SCNT are the same thing for the purposes that we're talking about right now, and that is creating a new cell line or a new individual from an existing cell line or an existing individual.
Therapeutic cloning refers to using a cloning procedure to make a stem cell line, whereas reproductive cloning refers to using a cloning procedure in order to create an entire new living organism.
But the procedure is the same. Therefore, all cloning or all SCNT should be considered reproductive, and then when the embryo is used for research, its organismal being, its life, is simply terminated at an early date. So I don't find that distinction a convincing differentiation. And furthermore, I really think it's not a good strategy for science to redefine terms in a way that obscures the reality of what's going on.
I always remind people, beware of euphemisms. And you'll see a lot of euphemisms when there's controversy, because people want to advance their position, their point of view. So we want to call things something other than what they really are, to tone it down, to make it sound like it's a wonderful, good thing that we're doing.
Even medical education materials have reflected this confusion of language and inaccurate science. One such video on the internet is Regenerative Medicine: Pathways to Cure.
With SCNT, the nucleus containing the DNA would be removed from the patient's somatic cell, such as skin or blood cells. The nucleus containing the patient's DNA would then be transferred into an empty, unfertilized donor egg that has had the donor's nucleus and DNA removed. This manufactured cell mass containing the patient's DNA is stimulated to divide, and after about 5 days will produce stem cells.
The key word that was omitted in that clip was the word embryo. Somatic cell nuclear transfer does not create a manufactured cell mass. The President's Council on Bioethics made it very clear, but so did President Clinton's Bioethics Advisory Council admit that somatic cell nuclear transfer creates an embryo.
What is the difference between an embryo from a fertilized egg and the cell mass created by SCNT? With SCNT, the DNA comes from the patient's somatic cell, not the union of a sperm cell and an egg cell. Without certain developmental components that originate in the sperm, the genes necessary for fetal development do not properly express.
If the statements made in that clip were true, Dolly would never have been born. Dolly was created through somatic cell nuclear transfer. So that kind of deception by science, frankly, it undermines science and corrupts science, because science is to tell us objective facts so that we can have the ability to engage in ethical analysis. What they're trying to do is play hide the ball.
Yes, these cells could theoretically have the potential, under very different circumstances, to develop into human beings. That potential is where their magic lies. But they are not, in and of themselves, human beings.
While scientists should know better regarding the scientific facts of stem cell research and cloning, celebrities may not. And the involvement of celebrities in promoting this same argument has created a difficult barrier to educating the public in the scientific and medical facts of the controversy over cloning human life. One of the most well-known cases of a celebrity involved in stem cell research and cloning was that of Christopher Reeve, loved and remembered for his movie role as Superman. Reeve, a man of heroic courage and spirit, had been paralyzed by a spinal injury and became an ardent promoter of embryonic stem cell research, making many appearances on national media. Because of his beloved celebrity status, those who questioned Reeve's claims would be stigmatized as uncompassionate, like a villain in a Superman movie.
But you are victim to another fatal weakness, your compassion. The death of others means more to you than your own.
Appearing on Charlie Rose, Reeve denied that therapeutic cloning was indeed the cloning of human life.
No, that's not what it is at all. That's not a. This is research cloning. This is cloning that does not create a human life, because a human life is a creation, created by the union of male and female. That doesn't happen in
When Reeve testified before the Senate Subcommittee on Health, he maintained that SCNT did not create embryonic human life unless it was implanted in a womb.
The unfertilized eggs that are going to be used for nucleus transplantation will never leave the laboratory, will never be implanted in a womb.
Implantation is not an act of cloning. Implantation is an act of implantation. To say that implanting a cloned embryo is cloning is as ridiculous as saying implanting a fertilized embryo is fertilization.
If the government forces scientists to attempt to make adult stem cells behave like embryonic stem cells, they might waste 5 years or more and fail. In the meantime, hundreds of thousands will have died.
At the time Reeve was speaking, in 2002, adult stem cell research had already accomplished more results toward saving lives in human trials than embryonic stem cell research. And 5 years later, embryonic stem cell research had failed to help a single human being.
Our government's supposed to do the greatest good for the greatest number of people.
The premise from the greater good argument is that early forms of human life can be used to rescue later forms of human life based on the argument of suffering. Right now we're talking about taking stem cells from a 4 to 5 day old embryo. Why would we stop there by that argument? Why not go to the 16th day or the 22nd or the 3rd month? So what is your criteria for when you would stop such a project? And by the way, the argument from suffering, in other words, that we should use human life instrumentally to deal with the suffering of other lives, that argument has no bottom.
The shifting use of definitions and euphemisms in the cloning debate has not only been developed in the scientific and medical communities and been picked up by celebrities in pop culture, it has also been strategically used by lawmakers. California's Proposition 71 became an example that would be followed around the country.
Proposition 71 was voted on by California voters, passed with about 60% of the vote, and it earmarks $3 billion over 10 years for stem cell research, in particular for embryonic stem cell research.
And hence we have a $3 billion fund, unmatched anywhere in the world for stem cell research. That's going to put this country, certainly this state, at the forefront of this technology, the only technology in the world that has the capacity to treat every single human disease. It's no small trick.
Those who opposed Proposition 71 claimed that it was indeed a trick on the citizens of California. An overwhelming majority do not support human cloning, but Proposition 71 only prohibits human reproductive cloning, not therapeutic cloning. This means that the cloning of human beings is not allowed for the purpose of pregnancy, but is allowed for the purpose of harvesting the cells of live human embryos.
Many of the arguments against Proposition 71, against stem cell research in general, have fallen away with the education that the American public has gained over the last few years, certainly with the campaigning for Proposition 71.
Now that more and more people have become educated, I meet a lot of people that say, I would never have voted for that if I could have my vote back again.
The antagonism really came from ignorance in much of the case.
I think it came from genuine moral objection. And I think that that moral objection is reasonably grounded. Those who opposed embryo-destructive research, including that which was necessary to get the embryonic stem cell lines, believed that there should be an inviolability to the human organism from fertilization onwards, and that the continuity of life justified that position.
The result was that Missouri, Maryland, Illinois, and other states went to their voters to permit funding and conducting of embryonic stem cell research.
The Missouri Amendment 2 campaign was one of the most deceptive that I have ever experienced. It was an utter disrespect for democracy in that state. You had, and the media went right along. For example, rather than calling it embryonic stem cells, they called them early stem cells. They said somatic cell nuclear transfer wasn't cloning, when of course it is cloning. That's the science. They said that somatic cell nuclear transfer creates stem cells. Somatic cell nuclear transfer doesn't create stem cells. It creates an embryo that is developed to a blastocyst, which is a 1-week-old embryo, from which stem cells are taken by destroying the embryo. And what makes it worse is that the in-the-tank media just went right along. And it was almost like Amendment 2 forces were Fred Astaire and the media was Ginger Rogers. They led and the media followed.
Like a ripple effect, scientists, medical doctors, the media, celebrities, and politicians have all been influenced by the changing definitions and scientific misinformation of the cloning agenda. Perhaps these political battles may never be resolved. Yet there are also scientific and medical reasons why many are claiming that cloning is not a justifiable pursuit for reproduction or research. One of those reasons is the inefficiency of cloning.
In fact, I recall one study saying that as many as 100 eggs might be necessary to obtain one embryonic stem cell line, and that was published in the Proceedings of the National Academy of Sciences. The number of eggs that would be required just to treat, say, about 20 million people in the United States alone who have diabetes. And if you just use even 10 eggs per patient, you're talking about 200 million eggs. The numbers are just staggering.
So why do you need more eggs? It's because we need more stem cells. Humans are big, and there's lots of us. We need a lot of tissue.
Now I see a shift where all of a sudden we have money entering in terms of research, and we see young women being looked at as a market for eggs. A woman has become a walking ovary factory, egg factory.
There's a very ethical, sound way to do this, and that is to compensate people for the expenses that they incurred, but don't entice them. No one's going to make an extra $1,000, $10,000 from donating their tissue. We can cover their expenses, but that's not an enticement.
Well, the last ad I saw in a campus newspaper was $100,000, and I can't imagine that the out-of-pocket expenses for an egg donor would be $100,000. Julia Derrick, who's written a book called The Confessions of a Serial Egg Donor, has been very candid and said, listen, whatever, girls are doing this for the money. And if you take the money out of it, they're not going to do it anymore. So whether we, again, euphemisms, change the language, well, we're not buying eggs, we're not paying for eggs. Well, there's money changing hands.
I find it particularly sad, the sense of the older, affluent woman in some societies is targeting the poorer, younger women in others and saying, I want your eggs, I want to use parts of your body because I want a child. So the older woman has got money, and so she can go and buy what she wants. It's just like another commodity.
They're going to go to the Congo. They're going to go to Bangladesh. They're going to go to Turkey. They're going to go to India and pay very destitute women a little amount of money, which to the women would be a lot, in order to get eggs so that they can do human cloning research.
I absolutely think that trading in human eggs is the newest form of human trafficking, because if you look at the heart of human trafficking is exploitation. It's, it's power of one over somebody else. Somebody needs something from you, and they're going to exploit you to get it. Whether that be they need workers for their sweatshop, whether they need children for their pornography, industry, or whether they need human eggs to help people make babies or to help the cloning researcher.
And there will be casualties in the wake of such proposals or such activities. Broken bodies and ill health for very poor women. Biological colonialism is in many ways like the old colonialism, exploitation of the weakest by the strong.
There was a very expressive picture in an article in Nature last year which showed a female torso without a head and without arms and legs, and all it showed was the ovaries of this woman, and the ovaries were represented as if it was a diamond mine. And I think that any woman who sees a picture like that should be absolutely horrified to feel that she's been reduced to such an impersonal state, that all she is a mine to be harvested, and this issue of taking eggs under any cost.
Cloning continues to be plagued by some of the very same problems that shadow embryonic stem cell research. It necessitates impossibly large quantities of women's eggs, procured through methods that exploit women and endanger their health and lives. It results in the creation and destruction of human embryonic life, and it creates an unknown amount of tumors in the process. So with all these mitigating factors, what can be done? Is there a way out of the ethical and scientific quagmire that cloning and embryonic stem cell research has found itself trapped in? Recent discoveries have provided an alternative to many ethical and medical health issues involved in both embryonic stem cell research and cloning. In November 2007, researchers in Wisconsin and Japan created what they called induced pluripotent stem cells.
Induced pluripotency cells, or IPS cells, are adult cells that have certain genes switched on, and it appears to return them to an early state, almost like an embryonic stem cell, to a pluripotent state. At least that's the theory.
The embryonic stem cells pluripotent, as we mentioned, compared to adult stem cells, which are multipotent. So the multipotent means they differentiate into cells in the organ compartment which they're in, but not others. Pluripotent means you can form any type of tissue, any organ compartment.
You could take a person's skin cell and make an embryonic stem cell line out of it. This is hugely important because it generates for you, your own, matched to you in every way, embryonic stem cell line, which can now be used to treat any disease you might have, with the exception of genetic diseases, that is, diseases that come from your own DNA.
There's a lot of hype around it. In every paper that comes out, there are more concerns about it. We don't even know what these cells are. We don't know if they're going to cause cancer when they're transplanted. We don't know if they can be transplanted. We need to continue work with SCNT, we need to continue work with iPS cells, and we need to find out what the value is for each of those two. And I think it may be that iPS cells are useful for some things and SCNT embryos are useful for other things.
One could argue that because of iPS cells, that derivation of new embryonic stem cell lines is obviated, it's completely unnecessary.
I think it's premature to say any one type of stem cell is better than another. The long-term relative merit and value of different type of stem cells is going to take time. It's going to take further research.
The idea that we should do it all is kind of a fallback position, because many of the politicized scientists used to say we need to focus on embryonic because they offer the only hope. That only hope thing has been busted wide open. So now they're saying, well, let's do it all. Well, that's a legitimate position if you think it's ethical to do it all. A lot of people don't.
iPS cells are not the only possible solution that research is coming up with to address the two competing values of scientific progress and moral concerns over human life.
A much better way forward would be to find a third option, one that met both the goals without violating anybody's moral conscience or scientific intentions. I proposed a project called Altered Nuclear Transfer, also called ANT. And the way this project works is you start by altering the initial ingredients before joining the nucleus of the adult cell with the cytoplasm or soup of the egg, such that what is joined together has an insufficiency, not a deficiency in a living being, but an insufficiency, an inadequacy, such that it cannot assemble the basic molecular dynamics for producing an embryo. However, it is capable of producing that single lineage of cells which goes on to form what is in the natural embryo the embryonic stem cells. So we can create exactly the same kinds of cells as embryonic stem cells through a process that does not involve a human embryo. So it sets the primacy of ethics and the promise of science together in a hopeful project for the future of medical science.
Several questions must be answered as we move ahead with the promise of stem cell research. The public needs to be better educated on the differences between adult stem cell research and embryonic stem cell research. While both forms are guided by regard for the alleviation of human suffering, embryonic stem cell research requires the destruction of living human embryos. Adult stem cell research does not. Embryonic stem cell research and human cloning require millions of eggs from women. But the harvesting of millions of eggs poses a dangerous threat to the health of these women. New breakthroughs, such as altered nuclear transfer, still require women's eggs to achieve its results. Yet adult stem cell research and induced pluripotent stem cells do not. And the latter may prove to satisfy the scientific demands of medical therapy while answering the ethical questions of social justice. Should we pursue all stem cell research options for the sake of scientific and medical progress? Will the public insist on moral restraints on such progress? Or will we seek to find cures at any cost? Will we be able to overcome the lines that divide?